the next speaker. This is Igor Szöke that will present the paper on detecting English speech in the air traffic control of voice communication.
Okay. Good morning, ladies and gentlemen. There is a large community of enthusiasts who mount antennas on their roofs, and if they live near the airports, they record the air traffic of incoming, outgoing traffic and listen to the pilot and ATCO communication. And in ATCO² project, we are building a worldwide platform which help these people to share the data, collect the data, and listen to the data. For who you are not familiar with the VHF radio data or how the speech sounds like, here is some examples. Not that.
Sydney Tower, good afternoon. FedEx 77 Heavy inbound ILS runway 16 right.
Okay, so this is how it sounds like, where everything goes well. Yeah, here is where the guy is near some local airport.
Speedbird 855, Roger, taxi only point on me 24, taxi right via Hotel Alpha.
And yeah, the next one, please.
Oh, that is the 051 continue approach. No, triple connector and the 051.
So you can see we face quite a strong non-native English speech. Near the local airports, there is even complete non-English speech. Please.
Foxtrot uniforme, le vent 250 degrés 9 nœuds, piste 5 autorisé atterrir.
And as we do not have control over where the antenna is placed, because we are not connected to the tower, but we record the data, or the enthusiasts record the data out of the radio space, we can face really difficult noise conditions. Please.
Echo Fox.
Okay, thanks. So, as you heard, the data has quite a nice variety of noise and English, non-English speech. And to provide, in the ATCO² project, to provide some good data, we need to do some filtering. We need to do some estimation of noise, get rid out of the bad data. And also we need to get rid of non-English speech, as we would like to provide in primarily the English speech only. And another good thing is that we will have the community, the human in the loop. So here these guys can listen to the data and eventually update the labels, update the ASR transcript. So in the end, we can also get some good annotated data. And my talk will be about the English, non-English speech estimation. So first it's important to define what is English speech in context of ATC speech. Here is a sentence, some utterance from the pilot, and you can see here a quite nice Czech name entity. Also in this communication there are local greetings. Still, probably this sentence can be considered as a valid English utterance. But the pilots can switch to the local language, and that's probably not the English speech. So we define several rules. The first rule is that we ignore the greetings. We ignore the language of the name entities because it's important information. And the decision is made on top of the numeral. So if the numeral is in English or the command is in English, then we say, okay, it's English speech. Otherwise, we consider it as non-English speech. And by the way, this is quite difficult for standard acoustic LID systems to decide between these because it's mixed of English, non-English words, but still it can be English utterance. Here is the pipeline of our system, and as in the ATCO we have the ASR component there, we were thinking if we can make the English non-English detector based on the ASR output. So let's see how it works. First, so the dataset we were testing on, we use two subsets. The first subset is based on the ATCO² recordings. It's a pair of English and Czech data, Czech language. And the second subset is called out of domain, and it's based on Hawaii data recorded from Keflavik airport. It is English and Icelandic pair. So the baseline acoustic system is based on quite state-of-the-art standard X-vector LID system trained on very nice amount of 21,000 hours of speech, 64 languages. And from this framework, we are extracting the X-vectors. And then for training the classifier, the English, non-English speech classifier, we take the ATC data and pass it through the X-vector extractor and then train Gaussian linear classifier to classify English, non-English classes. How it works? Well, it works quite nice. We achieved on the in-domain data, so the classifier was trained on the English, non-English, on the English-Czech pair. We achieved 9% equal error rate. And for the out-of-domain data, so the English-Icelandic language pair, so this data was not in the classifier training, we achieved about 20% equal error rate. So let's see how the ASR-based English language detector works. So first, we use two ASR systems. The main one is English ASR trained on the ATC domain. Karel Veselý will have in a few minutes a presentation about this ASR. And this ASR achieved about a 9% word error rate for Airbus and Mallorca data. And on the ATCO² data, we achieved 20% word error rate. This is due to the channel. Yeah, our channel is much more noisy. And to compare with, we also used a Czech ASR, which is quite good, state-of-the-art one, and you can consider it as on-the-shelf ASR, but this ASR was not adapted on the ATC domain. What we did, we just plugged in a few thousand words from ATC domain, like is the alphabet, airline designators. That's all. No language adaptation, no acoustic model adaptation. And you can see we achieved 80% word error rate on ATCO² data. So this ASR has no clue how sounds the Czech ATC speech. As the output of ASR, we are using CNETs or confusion networks, and the statistics of the words with the confidences we pulled together on one large heap and extracted back of words representation out of it. Then these statistics were passed into the TF-IDF technique, and again binary logistic regression classifier was trained on top of it again to classify to English, non-English speech. How this approach works? So this one is a bit better than the acoustic one, so that's good, a 7% word error rate and 18% word error rate. We also try to implement advanced Bayesian subspace multinomial model, where the back-of-words representation is passed to the Bayesian model. Then we extract low-dimensional Gaussian embeddings, and then these are again classified by logistic regression or the Gaussian linear classifier. Here, for the logistic regression, we are on the same level as the TF-IDF system, and for the Gaussian linear classifier, the in-domain data are a little bit worse. On the other hand, the out-domain or unseen data, the unseen pair English Icelandic language, are better. That's quite nice. So does it work? I think yes, it does work. And let's see some more results. So here is a table of how it works if we add the English Icelandic pair as a training data for the classifier. So here you can see, as expected, we get some nice gain in the out-domain data, which are now in-domain data. Next, let's see what happens with the ASRs. So when we run the English language detector on top of Czech ASR, or output of the Czech ASR, not the English, the Czech, what is very surprising is that the English-Czech pair achieved much better, or a little bit better accuracy than when it was trained on the English ASR, which may be caused, but as the Czech ASR is completely wrong, it just outputs garbage. Probably it outputs consistently the garbage. So the technique on top of it can very well decide if it is English and non-English. And as expected, the out-of-domain pair was quite worse. What is good that we can very easily combine these two ASRs. So we just take the statistics from English one, Czech one, put it again as a buck of words, and well, it combines well. We got another nice improvements here. And finally, what happens if we add also the unseen data, the English-Icelandic data pair into this beast? Again, some small improvement. So I think this technique is quite nicely scalable. So my conclusion, does the ASR English language detector works? Yes, it works. And I think it's at least the same accuracy as the state-of-the-art acoustic one, acoustic LID. Adding unseen data, of course, helps, which is good because we have human in the loop. So what we can do, when we collect some more data, we can readapt the systems and improve the accuracy. Adding more ASR also helps. So later, if we find out, okay, we need French ASR, we can plug it in and even get some nice improvements. One more thing, the results you saw here, you can't reevaluate because the English-Icelandic dataset will not be published due to some limitations in Hawaii project. But in the ATCO project, we decided to publish our datasets freely for research purposes. So the English-Czech pair is published together with English-French, English-German, and some of the Australian English data. So you can play with such this data. And as a bonus we decided also to publish 60 minutes of transcribed English ATC speech. So please visit the ATCO² website. You can download this data set and play with it. And one more thing, we need you. We need you to help us with collecting the data, to be part of the community of the data feeders. So if you have roof, you are near some airport, please enjoy mounting some camera as my son did. And well, but this is not advice to break your local legal things, because in some countries it's illegal to record. Thank you.
I think we have 1 or 2 minutes for questions, so are there any? Yes, we have one in the room.
Thank you. Okay.
Okay, Igor, thank you for the talk. And have you tried to combine the acoustic X-vector based model with the ASR based?
Good question. We are on it. Yeah, but yeah, it's obvious question. Try to combine and see if it does even better.
Okay.
Not
Thank
yet.
You. Thank you.
Any further quick, short question? If not, then thank you again for the interesting presentation. And I would like